Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at the quotient rule. So quotient means divide. You use this rule when you have one function of x divided by another. That's what this notation means, that u and v are both functions of x. So to differentiate such a function, we take derivative of the top times the bottom minus top times derivative of the bottom, and then all over the bottom squared. Okay, it's a bit more complicated than the product rule, but let's look at an example. Fx equals some function of x divided by some function of x, so we're going to use the quotient rule. So to differentiate this, on top we go derivative of the top, so derivative of x squared minus 1 is 2x, and then you multiply that by the bottom, minus the first, so here x squared minus 1, times by the derivative of the bottom. Now the derivative of this is just 1, so that's why I don't need to write it there. And that all goes over the bottom squared. So just see if you can simplify it. Sometimes you can, sometimes you can't. Expanding the top gives 2x squared, and then I get minus x squared plus 1 over x plus 1 squared. Okay, so I can just collect like terms on the top. It's x squared plus 2x plus 1, all divided by x plus 1 squared. But this is actually x plus 1 squared. So the derivative is actually x plus 1 squared over x plus 1 squared. So x plus 1 squared over x plus 1 squared is just 1. The derivative here is 1. And that's because there was an easier way to do this. I could have factorized the top as x plus 1 times x minus 1, and then I could have just cancelled out the x plus 1s like that. Differentiating x minus 1 just gives you 1. So it is true that when we have something like this, we see if we can factorize and make it easier first, because as you can see, the quotient rule is a little more complicated, but you won't always be able to do that. We won't be able to do that here. 2x e to the x squared. I mean, we could write this as 2x times e to the minus x squared and use the product rule, but we'll use the quotient rule here, which is pretty much the same effort, and then we'll simplify as much as we can. So if I'm differentiating this function here, so what I do is on top, I go derivative of the top times the bottom, so derivative of 2x is 2, and then multiply by the bottom e to the x squared. Then it's always a minus. It is the top times the derivative of the bottom. Now derivative of e to the x squared, I times by the derivative of the power, and I leave the x and the power alone. So on the bottom, I need to square this. So if you square e to the x squared, you actually get e to the 2x squared. All right, this one can be simplified a bit. So you can see on the top, both this term and this term have a common factor of 2e to the x squared. So take that as a factor, I'm left with 1 minus, so x times 2x is 2x squared. And that's all over e to the 2x squared. So I can now divide here, top and bottom, by e to the x squared. E to the 2x squared divide e to the x squared is just e to the x squared. So my final answer is 2 outside of 1 minus 2x squared over e to the x squared. And there we're done. We can't simplify it anymore. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.